Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week 37, which is our third and I believe final lesson on the topic of object-oriented programming. So the first of our three lessons on object-oriented programming, we looked at what it was and kind of theory and saw a bunch of pictures. Then in the last lesson, we looked at creating an object such as this, which had everything within it. So a single object, no inheritance or anything like that, just communicating via NetMiko, Napalm, or NC client as necessary. This lesson, we're going to look at inheritance, at least for most of the lesson. So we are going to create a base class called device, and then we're going to have subclasses called NetMiko device, Napalm device, NC client device, and we will put all the specific to the transport code inside each of these different subclasses so that all of the code for NetMiko is hidden in here. It makes things a lot cleaner and simpler from the user standpoint. It's pretty simple anyway. They always call connect, get facts, disconnect, etc. But the implementation underneath it is cleaner when we use this one level of inheritance. When we're done with that, we're going to look a little bit at object-oriented stuff in the wild. You are probably aware of the fact that you've been a consumer or a user of object-oriented stuff in a lot of the networking things that we did, whether it's Napalm or NetMiko or Nmap or whatever. They actually use object-oriented stuff and they create objects that you dealt with. You didn't have to implement them on your own, but you definitely called methods associated with them. And so we're going to look a little bit at that, and then we're going to look a little bit at what Quaka does with classes. It has a few class situations that it makes use of. Those classes, there's an example of a class for which just one instance is created, one object. That would be for threading. And then another, we have a static class situation. That's for managing threads that are doing our remote workers, such as communicating with a capture worker or a traceroute worker or what have you. So, and then the third case we'll be looking at is SQL Alchemy, which talks about, which involves doing stuff on the database and defining fields for the tables that will be in the database, and we do that using classes. So that's what we're going to be talking about. Hopefully it will be interesting and understandable to you. So let's get started. Okay, so today we talk about inheritance. Specifically, we are going to take our device object that we created in the last lesson and we are going to evolve it into something that looks more like this. In the previous incarnation, the one that we've already done, we have one device object and it supports these methods importantly, so the consumer or user of our object gets to call these methods and we will do it whatever is appropriate depending on whether the transport is NetMiko or Napalm or NC client. So that all works fine, but it actually ends up getting a little bit messy because my connect function has to implement logic depending on whether it's NetMiko or Napalm or NC client. And as we saw, it could get a little bit messy in my device application down here. My connect, I have these if statements. My get facts, I have if statements. And each of these, if I were to go down and look at one of them, so I climbing down into connect Napalm, I have this connect function and it includes connectivity stuff for NetMiko and for Napalm and for NC client. So it's a little bit a mix of object-oriented at the very top. My device object is object-oriented, but then we go back to doing things in fairly standard Python-y way, which is to say something such as what you see here on the left with a bunch of logic and a bunch of data. And so we were living in a world like this, but it was it had this one object, but it also had a fair amount of that stuff, which frankly can get ugly over time. So what we're going to do, instead of this in our inheritance lesson, we are going to do something like this. Instead of having one object called device, we're going to have a base object called device, which has stuff that is in common for every different type of device that I am going to be implementing. And then I'm going to have subclasses which are going to inherit from the base class. And NetMiko device, Napalm device, NC client device, these are all going to support their own version of connect and get fax and disconnect. I haven't done get config still. But the idea is that all the code that is unique to NetMiko is going to be located here in this connect function. So no longer do I have to have that big connect function that has a whole lot of code that can get kind of messy when you have to support all of these different transport types. Instead of doing that, I'm going to have that code implemented in the specific objects. And so let's look at what that is going to be like in the code. Okay, so just like in the last lesson, let's start from outside our implementation of device and look at the code that actually makes use of it. So over here, I have M06 classes. I have two files. And over here, I have M06B inheritance. You can see I've implemented another module 6. This is my module 6B. You can see some similarities. I have device there. I have device there. By the way, if you recall from the last lesson, I had device with a small d. I probably shouldn't have done that. There's not anything other than convention to dictate that I would capitalize that. But since typically for classes, certainly the classes start with a capital letter, then we have the module itself start with a capital letter as well. So I changed that just in case you're wondering if that's different from the other one. It's no different. I just changed the first letter D to be a capital D. But in M06 classes, you can see I have devices app down here. I also have devices app up here. In my single device implementation, I have device. Down here in inheritance, I have device, which is a base class, but I also have defined Napalm device, NC client device, and NetMiko device. Now up here, I needed this thing called connect, and I needed this thing called fax in order to implement in kind of that messy old style of doing things Python code. It wasn't bad per se, but it had all the different transport types in it, NetMiko, Napalm, and NC client. I no longer have to do that because all of the Napalm specific implementation stuff is in the Napalm device class, and all of the NC client is in NC client. All of the NetMiko stuff is in NetMiko, so I no longer need to have a separate module called connect or a separate module called fax. Now I do have miscellaneous types. That's kind of common across the consumer as well as the actual definition of this. And then as you'll see, I put some code in util because I thought it might be useful elsewhere. I'm not sure that's the best usage of that, but we'll get down and look at that when we get to it. But let's look at the code that actually does something. Now, I want you to recall this. If I bring this up, remember here, my device object, what methods did I define? I defined it connect, get fax, config, and get config and disconnect. In my actual drawing of inheritance, notice I have exactly the same thing. So I, as a user, will be calling connect, whether it's NetMiko or Napalm or NC client, and it will connect. The difference is there will be a different implementation for NetMiko and a different implementation for Napalm and a different implementation for NC client, but the code itself that's going to use it is going to be exactly the same. Here you see my inheritance version. I just call connect. Over here for my my one with just the one device object, I call connect as well. So even though I have three different implementations of connect, one for Napalm, one for NC client, and one for NetMiko, because I've defined it in this way with inheritance, then what I'm able to do is call this and it will do the appropriate thing. So this is an example of polymorphism or object overloading, although it's not really object overloading, it's just overloading the general idea that you can have a method of a particular name, and it will do something different depending on whether my device, see, my application doesn't even know what type of device this is, it just calls connect. Depending on the actual device I'm dealing with, is a napalm device, whoops, I didn't mean to double click that, or a NetMiko, an NC client device, or a NetMiko device. So the code here is exactly the same as the code there. So none of that has to change. It's just my underlying implementation. And the last thing before we go to the next thing that I want to point out is the fact that that this is one of the ideas that we had talked about before as the advantage of object-oriented stuff. If I were to scroll back here to the advantages, one of the things that you see is encapsulation. And because I've encapsulated the differences between Napalm, NC Client, and NetMiko, my user of my object does not have to worry about those separate details. All it has to do is call the connect method. All right, so next let's look at how these objects are actually created. Okay, so let's look at how we create these devices. Remember, this is the code that actually does something with them, but the first thing we do is we call create devices. And what exactly is create devices? That's the thing we're looking at right here. Now, over here is the way that we did it in the last lesson. And you remember what we did was we created an object based on this class device, and we passed in 4 different parameters. These 4 parameters included the name, host name, device type, and then we had to tell it the transport. And so we had to know that it was NetMiko. We had to indicate that this device was going to have an attribute associated with it, a member variable that says that the transport type is going to be NetMiko. In a similar manner, I had to pass in Napalm and NC Client when I created it. But in all of these cases, I'm creating something called a device. Now, what happens in our inheritance idea is instead of creating a device, I'm going to be creating either a NetMiko device or a Napalm device or an NC Client device. All right, so I'm calling this particular class, which is a subclass of our original, if I can bring this back up, it's a subclass of device, but I'm creating either a NetMiko device or a Napalm device or an NC Client device, depending on what access method I'm going to use for it. So NetMiko, Napalm, or NC Client. That's the first thing that you'll notice is different. The next thing you'll notice that's different is, hey, we lost a parameter that we're passing in to this class creation constructor. So this class constructor. Over here we had transport, and we don't need to pass in transport. Why not? Because we know that we're creating a NetMiko device or an Napalm device or an NC Client device. And when we do something, like when we say connect, this device object right here is either going to be a NetMiko object or an NC Client object or a Napalm object. So it will call the appropriate connect method for that type of device. Okay, so the fact that we created different device objects is going to help us to not have to worry about passing in that parameter that tells it what it is. And in my implementation, I'm no longer going to have if statements like I did in that connect function. If you recall, I had to have, not in the connect function, but in device, here it is over here, I had to have these if statements that would then call the correct connect, etc. And so we don't want to have to do that, and that is what we end up with in this situation. We no longer have to do it because we've created a specific instance of that class. All right, so let's go down and let's look at the code that actually implements the class itself. So here we are in the device module for my old way of doing it with a single device that did everything. And over here on the left, I have my device in which I'm doing inheritance. And so in this situation, device is a base class, and I'm going to create subclasses off of this one. So my implementation is very short. In fact, all I do is I have some of the common data that we're all going to be using defined right here. Set credentials is going to be common across all of my device types, whether it's a NetMiko device or a Napalm device or an NC client device. In addition to credentials, setting the port is going to be the same. So I can put these here, and guess what? When we look at our subclasses, in other words, NetMiko, I don't have to define set credentials or set port. I'm just inheriting that from my parent. So if we look at this picture here, let me pull this up once again. The idea would be, probably the better way to do this would be to say something like get or set credentials. So setting credentials is something that is common across all of these, as is setting the port. So I can implement that there. This would be a better way of looking at that. I should have done it in that way beforehand. But you get the general idea. Set credentials is something that is common to all of the subclasses. Therefore, I put the implementation of it into the base class. So that is my base class. And remember, we're about to leave this, but remember what this looked like. We had connect and get facts and all of this extra implementation. That is now going to get pushed down into the subclasses, the actual implementation, the actual code for it. And in the NetMiko device, of course, that functionality will be only related to NetMiko and Napalm, etc. So you can see how nice that is in terms of organizing everything and keeping everything clean and kind of pristine compared to the other way of doing stuff. Okay, so I'm going to get rid of my old way of doing that, and I'm going to close this up, and we're going to look at these new implementations now. So let me do NetMiko device. So just for kicks, I'm going to do this. I'm going to split this on the right, and I'm going to remove that. So this over here is my device. That is the base class, okay? Over here, sorry, on the left is my base class, and on the right is my subclass, which is NetMiko device. Now, the first thing to notice is that I have something, I have parentheses, and then something in parentheses. What's up with that? Well, this is how we indicate inheritance. So if you've seen class definitions that have parentheses after them, then what you know is that it's not calling into a function, but it is representing inheritance from a parent class, and my parent class is device. That means that all of this data that you see right here defined in my base class is available to my subclass, and these methods are applicable to my object even though I don't implement them here. So look at NetMiko device. Do I implement set credentials? I don't. Not over here. It's implemented in the base class. The same with set port. And just to refresh our memory, if I go back, actually I didn't need to do that. If I go to my devices app, remember here I am actually calling in to this device. I'm calling into set port. I'm not calling into a particular method that's been defined within Napalm device. I'm actually utilizing the set port that was defined for the base class. And so you'll see this a lot when we inherit from classes that are defined in some superclass. The base class is called a superclass, or the parent class is called a superclass. Then we get the benefit of everything that has been implemented in here. One thing I'll point out that I didn't, but when I started to jump to this, was the fact that connect, get facts, and disconnect, I could have just left this completely blank and deleted it, and things would have worked fine. However, good practice, because I know that whoever uses device as a parent class needs to implement connect, and needs to implement get facts, and needs to implement disconnect, or kind of our contract with how we're supposed to be doing things is going to be broken. In other words, if there was another class that I defined that did not implement connect, and I came here and said connect, that would cause an error. And so what I've done is I print this out. If we actually end up calling the base class or the superclass or the parent class version of connect, we know that something went wrong and we're going to throw an error. This is going to cause an exception. We're going to throw an exception. And so that is why over here in NetMiko device, I have implemented connect and get facts and disconnect. So base class, if it's defined in the base class and it's not defined in the subclass, then it uses whatever was defined in the base class. I don't have an example of this, but if I was to do my own set credentials under NetMiko device, I could actually do that, and then it would call into my set credentials here in the subclass. But in my situation, I only have set credentials and set port, and those are implemented in the base class, and I inherit those because I'm inheriting from device, and so I get those for free, and I don't have to re-implement them in any way. All right, so let's look at the more interesting stuff here. Let's look at connect. Well, what's here in connect? Hey, guess what? This is exactly taken out of my NetMiko code. This is how I connect if I'm using NetMiko, and that makes sense. So now I no longer have to have that funny connect module that had all the different implementations of connecting for Napalm and NetMiko, etc. I've got all my connect code logic right here in my NetMiko device, which makes sense. That's kind of how we would expect it to be. What about get facts? Well, the code that I did implement for get facts that we looked at in the last lesson, it now lives within get facts for NetMiko. And so if the device is a NetMiko type of device, then we're going to be calling into here. And disconnect, we're going to be calling connection.disconnect. And if I was to pop up Napalm device and NC client device, let's look at those. As you would expect, Napalm device, it's going to be pretty much the same. I'm going to inherit from device. I don't have to implement set credentials or set port. I do have to implement connect, and if I look at this code, guess what? This looks exactly like the code that I use to connect with Napalm. I get a driver, I get a connection, and then I do a connection.open. Now get facts, of course, remember how simple that was in our connect module? Well, sorry, in our facts module, it's equally easy right here, but this is all of my Napalm logic, which is just calling that function. And now my disconnect is actually calls the disconnect function for Napalm, which is actually a close function, because you recall at the beginning I did an open and at the end I did a close. Similar things for NC client device. With NC client device, I'm inheriting from the parent, which is device. My connect is an NC client type of connect where I do this manager.connect. My get facts, remember I only implemented one thing. If you recall from the output of this, then there's only one item here that I got, and that was the serial number. And so as you would expect, I'm only setting one thing here, and what I'm doing, because I was able to find out how to get the serial number by passing in this Yang model namespace XML stuff definition in order to get that. I was able to get the serial number, and then the serial number, actually all I had to do is XML to dict, and I was able to get it right here. Now the one thing I want to point out is this with my NetMiko device. I still have this function called get version from show and get uptime from show, and you may wonder where are those? Well, what I did was I created a utility module and I implemented them in the utility module. Why did I do that? I thought maybe in my wild imagination there may be another type of device that actually does show commands, and it might want to use this. Now, I don't have that in this situation, and so technically what I could have done, if I look here, I could have taken this util functionality and just stuffed it within NetMiko device. In fact, I thought about doing that this morning before I recorded, and then I said, I don't know if it's because I'm a future looking guy or if I'm lazy and prefer to sit on my butt, but I decided to leave it here in this util function on the under the auspices of, well, somebody may want to use this. It's kind of a common thing. And so, yeah, you remember, here's how I get my uptime, and then getting the version. Remember, I had to do regular expression. So I'm doing exactly the same thing in both of these situations, but in my second situation, I'm doing this wonderful thing, making use of inheritance and utilizing the fact that I can define a NetMiko device, Napalm device, NC client device. I can inherit all of these member variables that are stored that are common to everybody. And I also can make use of this common set credentials and set port that's common to everybody. But for connect and get fax and disconnect, those are all unique. And so they have separate implementations. And remember, the nice thing is for the guy who gets to use this software that I create, all they need to do, they don't have to know any of those details. We've encapsulated it within these classes, and we've done it in an intelligent, I hope you agree, object-oriented, inheritance-based way. All that the user has to do is go through and say connect, and it does it, whether it's NetMiko, Napalm, or NC Client. Get fax, and such as they are, partial implementation for a couple of these, we get them whether it's NetMiko or NC Client or Napalm, and the same thing with disconnect. So that, my friends, is how you use, how you can use functionality related to inheritance in order to create some nice object-oriented functionality that wouldn't have been available otherwise unless we had this nice object-oriented capabilities in Python. Oh, hey, there's one thing I forgot to describe. I skipped over it in my interest to get to connect and get fax, etc. And that's this little thing. Remember, what is this called? It starts with C, and it has to do with constructing your object. That's right, it's called a constructor. And Python, in its wisdom, has called it underscore underscore init underscore underscore. And when somebody creates that particular object, like up here where you actually create the object based on the class, it's going to be passing in name, host name, and device type. You can see here name, device type, and host name are all passed in. Now, what am I doing here? Well, the way that I can reference functions in my parent class is I can use this built-in function called super. So I call super and I say, hey, call your init functionality, and I want you to go and pass in these three items. And it will therefore come over here to my device base class, and it will call in this. Notice that in my situation here, let's see, which device is this? This is my device, the one with inheritance, and I have set transport. I actually didn't get rid of this in my implementation. Probably I could be getting rid of this. In fact, I'm going to do some edits in just a second, and we'll look and see how that works. But basically what this does is it's going to call into the parent in order to set these important things, name, device type, and host name. And remember, those things that are defined right here are accessible in my child class. So in fact, that's what I do. When I do something, I'm doing self.connection. Well, I define connection in the base class, but that is available to me down here in the subclass. So that is something to remember. So this is my init. Now, a couple of things that I want to test, and we'll see if it works. And One of them is, I don't think, typically this init, you may do some things of your own. In this situation, I'm not really doing anything on my own, so why do I even have this here? So why don't I just get rid of that? And if I get rid of that, then what will end up happening is this init will get called, and that's perfectly okay. And the second thing that I'm going to do is I'm going to get rid of, because this is my inheritance version of device, so I really don't even need this. So I'm going to get rid of that. Now it throws an error. I'm going to get rid of this. That looks okay. This looks okay. So let's give it a shot. I'm going to go ahead and run this thing, and let's see what happens when I do that. I need to make sure I run the correct one. Devices app 1 is the one that is associated with this one, which is in inheritance. So let's give it a shot. So I think this is an indication that my changes were successful and that the extra stuff that I commented out and then I deleted are not really necessary. Now, one thing I will point out as we're waiting for this to happen is not infrequently I get errors with this because this device ends up going down for some reason, or it stops responding to, I think with my Napalm, I think it's using the NX API, I believe. And then when I do NC Client, it's using netconf. This one up here seems to work all the time. My NetMiko one, it seems to work all the time unless the device itself is down. These other ones, when I'm connecting using Napalm or NC Client, then sometimes they fail. But fortunately, it turns out that they all worked correctly. So there we go. Let me clean up this code after I let you go, and then we will wrap up. So you may be wondering about examples of classes and objects in the wild in situations that you may have run across before. Well, in our class, when we did networking, in most of the examples that we created, we were users of classes and objects. And I'll just give you a couple of examples. One being Nmap. This one may be the most straightforward. So with Nmap, I imported this thing called port scanner. I probably already have a clue that this is going to be a class definition by the fact that it's capitalized the different words in camel case. So what I'm going to do is click on port scanner and do a Control B. This is going to take me down into the Nmap code. See, this is actually where Nmap got installed when I did a pip install, and it's the actual code. And it's taken me down to the init function. So I can see port scanner is a class. It's importing, its a parent class is object. There's reasons for that we don't have to go through right now. But if we were to look at it, here's our constructor. Remember, underscore underscore init underscore underscore, and it's got some things that were allegedly passed in. Look at these. These are the member data that it's using, and typically if it's going to be an internal thing, then we start it with an underscore. I didn't do that in my example, but they're doing that here. So here we have some initialization code, and also in that initialization we're actually running some actual code. So a regular expression is being created right there for version type stuff. There's a whole lot of things here, but hey, look, here is actually something with a def. That means that it's a method. So here's get map and map last output, etc. And hey, scan, that's exactly what we use. So this is an indication that this is exactly the code that got called into when we did our nmap example. And so I could look at this code, and I cannot recall if we looked at this code in the video that I recorded, but yeah, this is something, this is where that code is, this is where that mapping stuff happens. So that's one example. Another example that's representative of things that are trying to abstract communication with different devices like NetMiko, Napalm is this example. What Napalm is going to do in our example, remember we said get network driver. So we just imported Napalm and then we called this function called get network driver. And let's go into it and just take a look at what it says. I'm not going to go into all of the code because it's actually quite complicated, but let's read what it says. It says that this is going to search for a class. All right, so that's a class. We are familiar with that. Derived from, see there's a typo, form derived from the base Napalm class. Okay, so they're using inheritance. So it's going to be derived from network driver, and they're going to look for a class which is derived from it. So as you can imagine, depending on the vendor and maybe even the OS, you're going to get a different driver, and it's all going to come from these Napalm type classes that have been defined. Now the code that actually does that is fairly complicated and I'm not going to go into it, but you get the general idea that when we get something back, this driver thing, we get it back, that's actually going to be a class, and then from that class I'm going to create an instance of it. And in this situation, if it's NXOS, I create it like this, and if it is anything else, then I create it where I'm passing in this port, and I end up with an object called a Napalm device that's going to be of the type that was the class that was found when we called get network driver. Okay, I hope that kind of makes sense. Next, let's look at how Quaka uses classes. So let's talk about how classes are used in Quaka. So I'm going to go up to Quaka here and I'm going to say find me in files, class space. You see I've done that before, and you're going to see a number of things that are of this nature: capture manager and compliance monitor tasks. So you see a number of things that are tasks and some things that are manager. That's two different types of usages of class, and down here the other ones are just configuration file stuff. The ones down here are actually database related, and they are a third way that we're using classes. So let's take a quick look at these and see if we can figure out what's going on. So capture manager, if I go to this file and I look at capture manager, see I'm using this class, and I don't have an init. I don't reference self.something in any of this code. I'm using it as a static class. And if you are trying to remember when we talked about that, this was the use of normal objects where we would do self.whatever, self.variable or whatever. In the case where we have a static class, we're not using self at all. We're just using the class definition itself. There's one of them, and we are going to use it without any self-referential type stuff. So what you'll see is a little bit of code that gets executed when this gets imported. And then you're going to see a number of these methods, which are all listed as static methods. That means we don't have self, and so this is just going to get executed when I call it. There's one of these things for all of my application. And that's what my static method and this static type of class is used for. Now if we go back to our different type, I'm going to do Control Shift, whoops. I'm going to look for class space, and the other thing that I was going to look at was going to be a task. So why don't I do device monitor task, and let's have a look at that. My device monitor task is a class, and it has an initialization function, and you'll find all of these tasks that are associated with threads are set up this way. So I can create as many as I want, but in my application I only do create one of them. In that singleton model that we looked at, typically you will have something that prevents more than one of these classes or objects from getting instantiated. I haven't done that. It's possible that we might want to have multiple discovery tasks, so I didn't bother to do that. Plus, I wanted to keep it simple. But you'll notice I'm using self.terminate in this situation. That's for referring to my own data. Now, I don't really have a lot of my own data here, but monitor in this situation is what gets called on my thread. And so this will go through in my thread in order to discover device stuff. It's just like normal Python code. There's not really anything special. I'm not inheriting from anything else, but this is what my class usage for the tasks, that would be the thread, the class that I use for threading, looks like. Now the last one, let's do another one of these find in files, and let's go to the bottom here because this is what I wanted to show you. These, if you're familiar with Quaka at all, these are all of my database items here. So one of my device database items, let's do host just for kicks. So when we look at this example being host, you can see that I'm inheriting from db.model, and that when you look at the actual code here, you'll see that it looks a little bit less like code and more like declarative syntax for declaring actual variables. And in a sense, that's kind of what I'm doing, but what I'm doing is I'm declaring the columns that are going to be part of this class, which will be associated with the database table. So the way that I do that is I use this DB thing that is the actual SQL Alchemy database class, or it's actually the object that we created, and I am creating an instance of a column and passing in the type of data that it's going to be, and that will be associated with, in the database, the field for MAC address or IP address or name or whatever. So this will be a little bit more involved than what we've done in our lesson earlier with our device and NetMiko device, etc. But a lot of times you become a consumer of classes that somebody else has created, and you follow the model and the pattern that they have set up for declaring things. And in our situation, this is how you declare your class in SQL Alchemy that will be associated with the appropriate database table. In this case, it would be host. So that's our usage of classes in Quaka. It's not exactly the same. It's not even remotely the same as what we did in our example, but it at least gives you a little bit of an idea of the different ways that classes and objects can be used in a real world situation. Okay, so let's review what we talked about today. We talked about doing inheritance. Remember when we did it before in the last lesson, we just had a single device object and it did everything on its own. In this situation, we're using and utilizing inheritance so that we can create these subclasses of device that handle all of their own processing of connection and facts and disconnection and things of that nature. So it makes it much cleaner and easier in the long run. We looked at the code that used it. We saw that this code is exactly the same as it was before. That's because we have hidden all of the details, and you just do a connect, get facts, disconnect, etc. We talked about how you create the objects that we're creating, not just a device, but a NetMiko device. And that device, then we have a handle to it in our devices dictionary, and then we can just iterate through them and treat them all the same, even though one of them is a NetMiko device, one is a Napalm device, and one's an NC client device. We looked at the actual device class, which got a lot simpler. It just has a bunch of our data. It has some of the methods that we use that are common for all of the subclasses, and so they're implemented once right here. And then for the ones that are specific to the subclasses, we decided we would add a little bit of error checking, and if they're not implemented in the subclass, then we raise an error. And the subclasses, here's an example of the subclass for NetMiko. All we do is we've got the implementation of connect and of get facts and of disconnect. These are all specific to NetMiko. So the NetMiko only stuff is right here. And if we were to look at Napalm or NC Client, they too would have their own functionality to implement what was needed. We also went and we looked a little bit at how classes are used in the wild. In that situation, we did look at some of the stuff such as, I think we looked at the Napalm example with our Get Network driver, and we also looked at the Nmap example, and in that situation we looked at the port scanner. Then we looked and said, okay, well, is there any examples within Quaka of using classes? And so we saw that there was. In Quaka, we have this manager. So the capture manager is an example of a static class where we just basically have static methods that are implemented, and so everything gets called against this capture manager. We looked at device monitor task, which is going to be created in conjunction with a thread, and so there's one device monitor task that we're using, but it actually is an object instance. We know that because we're using self to refer to our own local data there. And so there could be multiple of these device monitor tasks. In my situation, I'm only using one. And lastly, our use of class, we looked at how SQL Alchemy uses it. Now, this is all database related, and it looks significantly different from what we have seen before. It actually looks like we're defining data structure, and we kind of are, because we're creating these columns in the class that are going to be implemented by this db.model, the SQL Alchemy functionality, and we're creating those, and that is going to be directly related to database table and the columns in the table. So that is what we talked about. Hopefully this has been useful to you to understand inheritance, and then a little bit about understanding this other type of usage of classes and objects as well. Hopefully it wasn't too much. As always, if you have questions, go ahead and send them to me. And hey, thanks for listening.